Welcome back to the Off-Peak, a video series from Charged Fleet covering just about any topic related to electric fleet vehicles, based on industry insights and semi-conducted interviews. Now, this is only episode 2, so there's no need to worry about us being at our peak just yet. I'm Martin Ramju, editor of Charged Fleet, and today we're going to highlight a topic that very much relates to our name: wireless EV charging, and how it saves time and money by charging vehicles during the off-peak periods of the grid. Before I get to the details, please remember to follow and connect with us on social media, subscribe to our YouTube channel, and sign up for our weekly Charged Fleet e-newsletter to stay up to date on the latest industry news and episodes of the off-peak. Today, I speak with Alex Grusin, the CEO of Witricity, a Boston area company that is testing and developing wireless charging systems for fleets. While plug-in charging now dominates and gets all the attention, wireless has the potential to offer a simpler, smarter, and cheaper infrastructure with fewer moving parts. Best of all, a recent Witricity study points to possible savings of 50% on total cost of ownership for electrified fleets. Alex Grusin can tell you a lot more in this previously recorded interview. Thank you for joining us, Alex Grusin, CEO of Witricity. I wanted to start off with the plug-in charging environment that we have now. That seems to be predominant among the first wave of EVs. And while I think most people can picture and understand what the wireless mode is or what wireless devices are, I thought maybe you could detail a little bit what are the technological and infrastructure challenges for wide-scale acceptance of wireless charging installations.
Well, thanks, Martin. Thanks for having me here today. I do think it's worth giving people a flavor of what it is we actually do at Witricity, and when we talk about wireless charging of electric vehicles, what that means, because it's actually quite different than most people's experience with wireless charging, right? Today, it would be maybe you have a smartphone, or maybe you have an electric toothbrush that you have to stick on a stand, right? And both of those use, a historical sort of application of induction, right? And often the term induction is used. But our company was founded in 2007 based on inventions at MIT from the mid-2000s of a technology known as magnetic resonance, which has some really important and unique properties for the wireless charging of electric vehicles. Our technology can charge just as fast as if you had plugged in. It's just as efficient as if you had plugged in. There's no moving parts. There's no maintenance. No vandalism. There's no labor required. There's no hassle. Park and walk away. That's the core, customer experience that we deliver. And the unique technological advances allowed you to have that system that could literally deliver as much power as if you plugged in, just as efficiently. And that tends to sort of blow people's minds that that's possible. Because, as I said, their experience is with something, like that's optimized for being thin and cheap in a phone, but that's not what we do. And just last year in 2020, the global standard was ratified for electric vehicle wireless charging. And we spent 4 years in China working on setting the Chinese national standard for wireless charging of EVs. And that was also ratified in 2020. So we're really at this really exciting time where, we've been developing this technology for over a decade. We've got the global standard set last year. And now we are coming out of the development phase and into the deployment phase.
You had mentioned that the speeds are about the same. Are there any instances where wireless charging is actually faster than plug-in charging in terms of how much time you need to charge a battery?
Right. So you don't have to go somewhere for an explicit act of charging. When you do that, you tend to have to, charge it fast, get it done quickly. So before you move it on to the task, where to take that vehicle off that charger to put another one onto it. What we're doing is operating at in process flow, which frankly increases the available time for charging, which lowers the peak energy demand, and I think will help drive cost out of electrification and hopefully accelerate deployment.
How would this work in a fleet configuration, the constant charging? Do you have, for example, a charger in the maintenance bay, then you have one in the parking place, and maybe at a satellite facility that's on the circuit? Kind of walk us through the detailed infrastructure for a fleet.
Yeah, in a fleet application, I think that what you're seeing is it's an implementation of opportunity charging, right? Which is, I call it power snacking, right? So the ability to just sort of casually top off in the natural act of using the vehicle. So for example, at the loading dock, right? So rather than having to take the vehicle to a charging location for a fast charge between shifts, you're using the hours that it's sitting at the loading dock, or in some cases on a middle mile truck at the unloading dock, as an opportunity to charge in a place where cables, connectors, chargers would be impractical, right? The wireless charging is completely is sort of out of sight, out of mind. You just the truck or van is there at the loading dock, it's being charged, you're not having to think about it. In transit, it would be at the bus stop, right? Again, you don't have to take the bus back to a bus barn, it's at the bus stop. And if you have one or two charging stations in a route, then potentially that bus can do full shift all day, full shift without ever having to return to a bus barn, right? So it's about putting the charging in process and in flow of the vehicle.
Now, for those fleet managers who are confronted with having to install the infrastructure, who are electrifying their fleets, and a lot of them are at that first stage, how do the maintenance, repair, and installation costs compare for wireless versus the conventional plug-in charging equipment?
Sure. Well, so first of all, there's nothing to maintain. There's no moving parts. It can be embedded in the ground. There's nothing to vandalize. There's no labor required. It's just inherently much more robust, right? Especially in all weather. The cables, connectors are driven over. They ice over. They wear out. And so, wireless charging effectively becomes the maintenance-free solution. And yet we deliver the power, at the same speeds and same efficiency as if you plugged in. I think the interesting conversation for commercial fleet application is really total cost of ownership, right? We just finished a study with a major global logistics company, and we did a full total cost of ownership study for them. They are in the planning stages of a 200 van depot to serve a major metro area. Right? They were running 2 shifts a day, and they had to fit the charging of the vehicle between shifts to cover their full route deployment. Right? And so to do that, they were planning to deploy 250 kilowatt DC fast chargers. And what we worked with them on to show was that if you shifted your charging to being at the loading dock and the time that the vehicles are sitting there and idle, we doubled the amount of time that was available for charging. It took their power requirements for the whole site from 10 megawatts to 5 megawatts, right? It meant that their demand charges from the utility company dropped dramatically, right? They did not need a new substation from the utility company. So their build out was both less expensive, and faster, right? Their backup generation requirements reduced, right? So I think what we have to always look at in this move to electrification is what are the things we can do operationally to reduce the peak power requirement. And I think just nationally, from a grid impact point of view, that's going to be very important. But more tactically, for a particular rollout, anything you can do to reduce your peak power becomes important.
One of the things I was curious about when it comes to ROI and cost savings, is there any variation in TCO depending on the type of fleet or the size of vehicles within that fleet? Is there more savings if, let's say, you have a corporate pharmaceutical sedan fleet versus a heavy-duty trucking fleet?
I think that if you're talking about a sedan and you have extended periods of time, like you're only using it during the day and it's sitting there overnight, then again, this idea of slower charging for less power and less cost and less expense becomes important. You are also able to, park the vehicles more densely, but I think that the strongest benefit for us in that context is going to be the fact that you will always return to a vehicle that is charged and ready to go.
Well, there's certainly a lot of exciting developments to look forward to. And we certainly thank you for joining us. We definitely want to keep up with what's going on at Witricity, and hope you'll definitely be back.
Thank you very much. The future is autonomous. The future is wireless, and thank goodness the future is electric. I think the whole industry is moving in the right direction.
Well, that's all the time we have for today. A special thank you to Alex Grusin and the staff at Witricity for their insights. Let us know down in the comments any of your thoughts or views about wireless charging. And be sure to hit like on the YouTube video. Let us know how we're doing. This is a fairly new topic getting more attention throughout the EV fleet sector, so we'll be sure to delve into it more in future episodes. I'm Martin Ramji with Charged Fleet. Thank you for joining us, and we hope to see you again here on another episode of The Off Peak.